right? When we were talking about exothermic reactions, api discuss kara neutralization reactions. Okay, so if you can remember these neutralization reactions, it was like this. Okay, an acid, okay, an acid reacts with a base. Okay, an acid reacts with a base. Okay, during this reaction, water will be produced. Before water, a salt will be produced. A salt will be produced, and then water will be produced. And then this reaction is a reaction which gives out heat, right? So this is a reaction which gives out heat. So this is an exothermic reaction. Okay. So this is an exothermic reaction. That's what we studied on the last day. So if there is an acid and a base reacts together, a salt plus water will be produced, and as a result, heat will be produced. So it's an exothermic reaction. So now we are going to perform an exothermic reaction. We are going to perform a neutralization reaction, and then we are trying to calculate the amount of heat which is going to lose during the reaction. Okay, not lose, actually we are going to calculate the amount of heat given out to the external environment during this reaction. Okay, so then write a heading for this. Right head. Now we are known to this, right? We know that when acids and bases are reacted, heat will be given out. So we are going to take a particular acid with a concentration some amount. We are going to take a particular base with a concentration some amount, and then when we react the given amount of acid and the base together, we are going to calculate how much of heat that is going to be released during the reaction. That's what our task is. Okay, so write the heading. Right now we are going to understand what we have practically studied. Okay, so before that, this heat exchange during a reaction, heat exchange during a reaction can be calculated by a equation. I'll give you that view. Just write it like this: heat exchange taking place during a chemical reaction. It's a heading. Heat exchange taking place during a chemical reaction. Heat exchange taking place during a chemical reaction can be calculated. Heat exchange taking place during a chemical reaction can be calculated by the following equation. Heat exchange taking place during a chemical reaction can be calculated by the following equation. Okay, so now see the equation. That's very important. See it, right? Okay, this is Q. This is Q equals MC theta. These are two different letters. This is Q and this is theta. Okay, so Q stands for heat exchange. Amount of heat exchange, actually. Amount of heat exchange. Okay, so Q stands for the amount of heat exchange that is calculated basically in joules or kilojoules. You can use both. Okay, joules, when you divide it by 1000, you can convert it into kilojoules. Okay, right. Then M is mass of the reactants. Okay, so mass of the reactants is usually calculated in kilograms. Okay, and then this C is a simple. Okay, not the capital C. This is a simple C. C is the specific heat capacity of reactants. Okay, I'll tell you what specific heat capacity. Specific heat capacity of reactants. Specific heat capacity of reactants. Okay, that is usually calculated. It has the longest SI unit. Just see, wait to see that. Specific heat capacity of reactants is usually calculated with joules per kilogram per degree Celsius. That's long. The unit is long. joules per kilogram per degree Celsius. And then theta is temperature change. Okay, theta is the temperature change. Okay, and that is calculated in degree Celsius. You can first write down this equation. This is what the equation that we're going to use to calculate the amount of heat exchange during chemical reaction. So if it is a exothermic reaction, to calculate how much of heat energy was lost to the environment, we're going to use this equation. If it is an endothermic reaction, to calculate the amount of heat absorbed into the chemical reaction, again we are going to use the same equation. Right, quickly note it down. Okay, I hope you should be done. Right, let's quickly move into the next part. Okay, is anyone still writing the equation? Can you just tell me by putting up your hand? Harani, so let's quickly move into the next one. Write the main heading. Okay, write a heading like this. Determination of the heat exchange. Determination of the heat exchange. Determination of the heat exchange between the reaction of HCl, HCl, when you write HCl, make sure that you write it like this, okay? HCl, okay, that is an aqueous, okay? So write it like this. Determination of the heat exchange during the reaction of HCl, aqueous, plus NaOH, plus NaOH. Sorry, don't write plus, HCl and NaOH. HCl and NaOH, right? HCl and NaOH. You can write in the heading HCl and NaOH, but in the reaction you have to write it like this. Okay. So what are we going to do? We're going to react HCl, which is an aqueous, which is in the aqueous form, with NaOH, which is in the aqueous form. This is basically an acid. Okay. This is basically an acid. Okay. This is basically a base. All right. So when these two react, actually there will be a salt produced, which is called sodium chloride. This is the common salt that we are known with, right? This is the salt that is produced. There are many types of salts, but here the type of salt produced is what we are commonly known with, right? The common general salt that we use for cooking purposes, that is the salt which is produced over here, right? All right, hold on. Right, salt, and then water will be produced here. Okay, okay, so water will be produced here, H2O, that is in the form of liquid. Meantime, here heat is produced. Okay, so this amount of heat produced in the reaction is the thing what we are going to calculate here, right? Quickly write it. So these are things basically produced here. So what are we going to react? An acid called HCl with a base called NaOH. When these two react, a salt called NaCl will be produced. Meantime, what is produced, and then for sure heat is produced because this is an exothermic reaction. So we're going to calculate the amount of heat produced, amount of heat was released during the released to the external environment during the chemical reaction by using the equation that we previously learned. By using this equation, we're going to calculate how much of energy was produced during this reaction. Okay, note it down. Right, it's like this. So then write like this. You can write this also in the same reaction. Okay, so see like this. We use like in the same reaction we could write it. We use HCl with a concentration of 2 moles per decimeter cube. With a concentration of 2 moles per decimeter cube, a volume of 50 centimeter cubes. A volume of 50 centimeter cubes. Okay. We use sodium hydroxide with a concentration of 2 moles per decimeter cube. I hope you can remember the concentration. And then a volume of 50 centimeter cubes. Okay, now you know the amount of HCl and sodium hydroxide reacted. Okay, so basically I have used 50 centimeter cubes of HCl with a concentration of 2 moles per decimeter cube. I have used 50 centimeter cubes of sodium hydroxide with a concentration of 2 moles per decimeter cube. Now you know the concentrations of these two chemicals and how much of volume the chemicals used in the reaction. So you can now simply use the equation to calculate the amount of heat. We need some more details, but basically note it down. Right, okay, quickly note it down. Just note this down, these two, the amount of sodium hydroxide and HCl gonna use with the concentrations. And then we can write a point, right? The above, I hope you wrote it. Quickly write it. Quickly write it. Okay, and then write a point. The above reaction is an exothermic reaction. The above reaction is an exothermic reaction. The above reaction is an exothermic reaction. The above reaction is an exothermic reaction, which will release heat, to the external environment. The above reaction is an exothermic reaction which will release heat to the external environment. Which can be calculated by using Q equals mc theta. Right? The above reaction is an exothermic reaction which will release heat to the external environment, which could be calculated by using, try the equation, Q equals mc theta. Okay, all right. Hari. Then අපි දන්නවා react කරන්නේ HCl with sodium hydroxide. We know the amounts of HCl and sodium hydroxide used in this reaction, and we know the products which are going to produce, and we want to calculate the amount of heat released. Okay, so now I'm going to do a sketch for you. How would this reaction be? Simply it's like this. Okay, now see. Okay, now I have something like this. Okay, just be careful and watch it. Right, I have a container of HCl. Okay, I have a container of HCl like this. Okay, a container of HCl like this. Okay, I have a container of HCl here. Right, because I will need this diagram later also. I have HCl here. I'll just mark it as HCl. So the concentration of HCl here is 2 moles per decimeter cube. 2 moles per decimeter cube. All right. The volume here is 50 centimeter cubes. Okay, 50 centimeter cubes volume I have. Okay, and then I have sodium hydroxide here. of sodium hydroxide here with the same volume and the same concentration. Same volume and the same concentration. The only thing is the chemical is different. This is sodium hydroxide. What do? I add them together. I can't add them together in these two containers. What do? I take another separate container. And then it's a, let's say it's a big container like this. Okay, quite a large one. Okay, and then what do? I add both of them here. Right? I add both of them here. So then finally, I have a mixture here. What and what? I have HCl here, and I have what? NaOH here. Okay, NaOH here. I have 2 moles per decimeter cube HCl. How much? 50 centimeter cubes. And then I have 2 moles per decimeter cube of NaOH. How much of volume? 50 centimeter cubes. So altogether in this container, if you consider the overall volume, I have 100 centimeter cubes of solutions. I have 100 centimeter cube of a mixture here. Mixture of what and what? Sodium hydroxide and HCl. Now, when I introduce both of them together, right? When I let them mix together, what will happen? They'll start to react, right? Then sodium hydroxide with HCl meet to they will start doing reaction. When they are separate, they will not react, but when they meet each other, they will start doing the reaction. Okay. And then during this reaction, what will happen? The heat will be lost to the external environment. Okay. Heat will be lost to the external environment. Now my problem is to calculate how much of heat was lost during the external lost to the external environment during the reaction. Okay. Calculate. What do I have? I have HCl with this concentration, this much of a volume, sodium hydroxide with this concentration, this much of a volume. I'm going to mix them together to form a final mixture, which has a volume of 100 centimeter cubes, and then the mixture will start up doing chemical reaction, which is an exothermic reaction that releases heat to the external environment. My aim is to calculate the amount of heat which is going to be lost to the external environment. Mage aim එක තමයි මේ එළියට යන heat amount එක calculate කරගන්න. Okay, right? Okay, so quickly go for it. Elisha, you didn't miss much, right? You didn't miss much. I was just sketching the අපි දැන් මේ කරන්න යන practical එක sketch කරා මෙහෙමයි කරන්න යන්නේ කියලා. So then you can quickly go for this diagram. Okay, till everyone draws, I'll just did you guys understand the plan of our activity? අපි කරන්න යන වැඩේ තේරිච්ච කට්ටිය මට පොඩ්ඩක් response එකක් දෙන්න. අපි කරන්න යන වැඩේ තේරිච්ච කට්ටිය. ළමයි, are you all there? අපි කරන්න යන වැඩේ තේරිච්ච කට්ටිය අත උස්සන්න මට පොඩ්ඩක්. Okay, Shana, right? Okay. Okay, right. Okay. Quickly draw it. Right. Okay. So now imagine this question goes to Elia. Eli, just you can answer it. Eli hitanda. Now we have a container. Okay, we have a container. All right. So in this container, inside of this container, the temperature is 25 degrees Celsius. Okay. Inside of this container, the temperature is 25 degrees Celsius. Okay. And the external environment's temperature is 25 degrees Celsius as well. Okay. Now, Eli, you got to tell me into which direction the heat could flow. I'm giving you 2 options. Option number 1, heat from the container goes out. Okay. Option number 2, heat from the external environment flows into the container. What do you think happens, right? So I'm clearly telling you the container temperature, container has reactants. Just imagine container has some reactants. The temperature inside the container is 25 degrees Celsius and the external environment's temperature is also 25 degrees Celsius. Option number 1, container can heat එක එළියට loss වෙනවා. Option number 2, external environment can heat එක container එක ඇතුළට එනවා. What do you think would happen? Ellie, it's your question.
Sir, I'm not sure.
No, you have to tell me something so then we can just analyze it and see whether it's correct or not. Okay.
Heat goes out.
All right. Now, Ellie, just understand. Okay. All right. Upe, what is your answer?
Anissa, could you repeat the question, please?
Yeah. It's like this. You have a container with some reactants, let's say. The
Yeah.
temperature inside of the container is 25 degrees Celsius, and the external environment also has a temperature 25 degrees Celsius. Okay. So then I'm
Yeah.
asking you, what would happen? The heat from the container will lost to the external environment, or from the environment, the heat comes into the container. Okay. What's your idea? Upe, what's your idea?
So the heat will go out of the container.
All right. Shanafi, what's your idea?
So the heat, the inside the container will go out, right? But the outer part of the container will still be hot because of the external environment
I'm asking.
temperature.
No. I'm just asking one thing. Heat will release into the external environment, or from the environment, heat flows in.
I feel like from the environment, heat will.
Heat comes out. Heat comes
Yeah.
in. Okay, Bima, what is your idea?
No change.
No change. Nothing happens. Right? Lama yahagan. Nothing happens. Okay. Why is it? May balang external environment get in a temperature at 25. Reaction get in a temperature at 25. Okay. So both the environment, both the situation, both these places are at a thermal equilibrium. දෙන්නගේම තියෙන temperature එක equal. එහෙන් heat එක මෙහෙට එන්නෙත් නැහැ, මෙහෙන් heat එක එහෙට යන්නෙත් නැහැ. දෙන්නම is at the same level. Did you understand?
Yeah, sir.
Okay, what about you?
Sir, question. Then, okay, is there some sort of reaction that's happening, or is it like?
Yeah,
because,
sir. Like,
because if there's a reaction, then heat should go out.
Okay, listen. Take a while.
no, that's a
Okay,
really
I
silly
told at the
question.
very beginning there is a reaction happen, but still I didn't mention what sort of a reaction it is. I just mentioned the temperature inside the ring. Why did you feel? Did you
Sir,
feel
I
bad?
felt so dumb
Okay,
after
I know. I know. It's like this, okay? So that just I told you that there's a reaction is taking place. That's okay, but the temperature inside of the reaction chamber is 25. I didn't mention it's an exothermic or endothermic reaction. I didn't mention any, right? But I still mentioned there is a chemical reaction or whatever the things. Whatever I mentioned, the temperature inside the container is 25. So the temperature outside the environment is 25. So both the situation have the same temperature, which means these two positions are at a thermal equilibrium. Heat will not be released into the external environment, or heat will come in. So now you would understand. Upe, now can you tell me if the heat is to be released into the external environment, tell me where the heat should be high. Where should you have the higher temperature, right? Now, if it is an exothermic reaction, you have learned the reaction will emit heat to the external environment. So I'm asking you, if it is an exothermic reaction, where would the temperature should be high? Upe,
Outside the container?
heat should go out, bang. Heat should go out. Nangi, Upe, heat should go out. Like okay. Let's just reveal what Upe said. So let's come up with some numerical values. Okay, inside the temperature 25, outside the temperature 30. What do you can understand now, Upe?
එළිය ඇතුළට වඩා රස්නේ.
Hariva, right? Okay, I know. So that is it an exothermic reaction? එළියට ගිහිල්ලාද heat එක? Now take you as an example. Okay, take you as an example. This is Upe, yeah. Okay, Upe's body temperature is 36. Let's imagine. Okay, Upe goes to Nuvareliya, which is somewhere around 18 degrees Celsius. What do you feel, Upe?
feel cold.
You feel cold because your body temperature goes out. It goes out and your internal body temperature drops down. Then you were at 36. When you go to a cold condition, the environment has a lower temperature than yours, but your body. So your body temperature goes out. Your body heat goes out. So your body temperature drops down. If it drops down like 34 degrees Celsius, would you feel a difference? You were at 36. Since the external environment temperature is low, your body heat flows out and your initial body temperature drops down to 40. Do you feel cold? Yes, you. Why? Your initial body temperature was 36. Now you have fallen down to 34. Now you feel cold. How did this temperature was dropped down and you felt cold? Because your heat from the body was lost to the external environment. Do you understand?
Yeah.
Now this is Rupe. Now Rupe go to Qatar to watch FIFA. Okay, and her body temperature is 36, and Qatar's environmental temperature is 40. Now what would happen? Heat from your body goes out, or heat comes into your body? Upe, what happens?
Comes in.
Then what your body temperature would do? Would it stay in this level or would it try to increase? What would happen? Upe, what would happen? When you go to Qatar, your external environment temperature is 40 and your body temperature is 36. When heat comes in, what would happen to your body temperature? Will it be maintained at 36 or would it try to rise up?
It will increase.
Then how do you feel?
Warm.
Hey. So do you understand? Did you understand? Put up your hand, those who understood this situation. Shanuki, okay. Eli, was it okay to you?
Yes.
Elisha, was it? Yeah. So that means if the external environment temperature is low, from your body the heat goes out. If the external environmental temperature is high, then your body temperature heat comes in. Now, Upe, tell me what would happen in this situation. Now tell me what would happen in this situation.
The heat will come in.
Do you understand?
Yeah.
So we don't want this situation. We want the situation which is opposite to this, isn't it? So I just asked you, if it is an exothermic reaction, what should be the temperature inside the reaction chamber, and what should be the temperature outside the reaction chamber? Tell me. So the question is with you, Upe. Temperature inside the reaction chamber should be
Increased. If it's
should be
coming.
high,
Yeah.
and the temperature outside the reaction chamber should be less, isn't it?
Yeah.
Like it was, just imagine like this, it was, if it was 13 and if it was 25, now heat is higher inside the reaction chamber, heat is less outside the reaction chamber. Now the heat will go out. Do you understand? Eli, is it clear? Bima, is it clear? Shanuki, is it clear?
Yes, sir.
Okay. Eli, is it clear?
Yes, sir.
Okay. Now the simple thing is, when the reaction is happening, okay? Now let's just imagine, the sodium hydroxide is not yet reacted, okay? HCl is not yet reacted. So they are at the initial temperature levels. Right? So let's imagine they have the room temperature, which is 25 degrees Celsius. I'm just imagining, right? They have the room temperature, which is 25 degrees Celsius. Here they have the initial temperature, which is 25 degrees Celsius. When they to react, if it is an exothermic reaction, what should happen to the temperature here? It should go higher than these two or not? if this need to release out heat, now 25 is the normal room temperature, that means here in the environment also you have 25. So before the reaction of sodium hydroxide and HCl, when they were reactants, before the reaction, they had the initial temperature as the room temperature. Okay. Now I'm asking if this is an exothermic reaction, when they are getting reacted, what should happen to the temperature inside the chamber? Should it remain at 25, or when they were mixed together, temperature should rise up? What is your idea?
It should rise up, right, sir?
Upe, what is your idea?
It will increase.
Ah, thank God. Eli, what is your idea?
It should rise up, sir.
Ah, right, okay. The problem is, Upesh should have never been to do a radio somewhere, I think. I think you should have had a very bad science teacher when you were young, huh? Like in small grade. Or else you should have irritated the science class a lot. Young. Right, okay.
Ne?
Right.
No.
Right, okay. Right, all right. So then what happens when they are getting reacted, the temperature of the final mix should rise up. Rise up beyond the temperatures of the initial two reactants. Okay, right. So then we have some challenges in the equation, right? We had the equation. Where's the equation now? Right. All right. Okay, I'll take this equation. Co-equation. Okay. Right. Okay, so we have this equation. So first of all, we have to put values to all of these components. Theta, C, M, everything has to be found. Right. First, let's deal with theta. Right. First, let's deal with theta. Theta, if you can remember, it's a temperature change. Okay. Temperature change. Don't write it. It was a temperature change. It can mean temperature ke difference that they are asking. Okay. Temperature change means temperature final minus temperature initial. Okay, temperature change is a temperature final and temperature final subtracted by temperature initial. The difference between the two temperatures. Then you can feel it. But as I told you, before the reactions, initially reactants have a lower temperature before the reaction. But when they were reacted together in the mixture, the temperature increases. එහෙනම් 25 වලට වඩා temperature final එකක් මෙතන එනවා. Let's imagine some value. Temperature final will be a greater value than the initial temperature. So temperature final එකෙන් මේ temperature initial එක අඩු කරපුවාම you can calculate theta. You can calculate theta, the temperature difference. Is it clear to you? Right? Then theta එකේ අපි හොයන්නේ temperature change එකක්. Okay, temperature change එකක්. Temperature change එක හොයන්නේ කොහොමද? Temperature final එකෙන් temperature initial එක අඩු කරනවා. Right? What is temperature final here? As I told you, initial temperature තමයි මේ දෙන්න react වෙන්න කලින්. So that temperature is generally a low temperature value. Okay? So when they are getting reacted, the final temperature is quite a large value, quite a higher number than the initial temperature. So temperature final, just imagine like if it was like third temperature final, temperature initial is 25. So when you subtract, when you find out the difference between the temperature initial and final, 5 degrees Celsius. Likewise, you have to know that final temperature value will be a greater value in an exothermic reaction. So initial temperature, the temperature of the environment, right? We have some other problems also when we are calculating the initial temperature as well, right? But still the temperature initial is a lower value than the final temperature in this reaction. You can simply subtract the initial temperature by the final temperature to get the temperature change. Right? Quickly write like this. Write a point. When calculating the temperature change, when calculating the temperature change, when calculating the temperature change, within brackets theta, temperature final of the reaction, TF within brackets. temperature final within brackets Tf of the reaction, temperature final Tf of the reaction, temperature final Tf of the reaction should be found hold on. And sorry, yeah. When finding the final temperature of the when finding the temperature change within brackets theta of the reaction, temperature initial of the reactants, temperature initial of the reactants, temperature initial of the reactants, temperature initial of the reactants has to be subtracted, temperature initial of the reactants has to be subtracted, temperature initial of the reactants has to be subtracted from the temperature final. Temperature initial, you should have written it in brackets. Temperature initial, temperature I of reactants has to be subtracted from temperature final of the reaction. Of the reaction. Okay. So what did I say? When you're calculating theta, don't write Q for theta. Theta කියලා ලියන්න. Theta is this. Theta, when you're finding out theta, what do you have to do? Temperature final වලින් temperature initial subtract කරන්න. Go for it. Write this equation under the statement. When you are finding out theta, what you have to do? Temperature final වලින් temperature initial subtract කරන්න. Right? Then I'll introduce what is temperature final. Temperature final කියන්නේ temperature of the final mixture. Temperature of the final mixture. Okay. Temperature final කියන්නේ temperature of the final mixture. Then our mix වෙලා ඉන්නකොට final temperature. And temperature initial is temperature of the reactants. Okay. Temperature of the reactants. ඒ කියන්නේ මේ react වෙන්න කලින් temperature එක. දෙන්න react වෙන්න කලින් individually දෙන්නගේ temperature එක. Before the reaction, temperature of the reactants is considered as temperature initial. එයාට වඩා final temperature එක වැඩි දෙනවා mix කරපුවම react වෙනකොට final temperature එක වැඩි. And that is considered as temperature final. So how to find out the temperature difference? Theta, subtract temperature initial by the temperature final. Right, go for it. Right. So we are going to talk about all the challenges that we face when we are conducting an experiment like this. Okay. Right. Let's see. Right. Done. Lamai done. Lamai, are you all done? Hello.
Yes, sir.
Okay. Hey, talk with me. Yeah. Right. Okay. Right. Now the problem is, okay. Right. Fine. Okay. First, you need to find out temperature initial. Okay. You need to find out what's temperature initial. Hold on to see whether it erases. Yes. Okay. See here. Now, දැන් මෙන්න මෙහෙම case එකක් තියෙනවා ළමයි. හරිද? මේකයි case එක. Then we have to calculate the temperature final and the temperature initial. Let's deal with temperature initial first. Okay. Okay. Now, as I told you temperature initial of both of these reactant is 25. The temperature initial of this is going to be 25 degrees Celsius, and the temperature initial of this reactant also is going to be 25 degrees Celsius. Marafaya, you're so lucky. So then simply you can, because initial temperature of the two reactants then again similar. Mara lucky where temperature initial can be considered as 25 degrees Celsius. May reactants then again initial temperature before the reaction temperature equal. So then you can simply put initial temperature is 25. Right? Then again 25. Have I just imagine initial temperature is of one of these reactant is 26. Okay. Then initial temperature 25, initial temperature 26. Now tell me what you are now going to be considering as temperature initial. Then the temperature initial of the reactants consider karana. Isla situation ke temperature initial of the reactants consider karane ka mara easy ne. Then again initial temperature was 25 and 25. No problem. You could use the initial temperature of the reactant is 25. Then the temperature initial kila consider karane. Moka dekkene 26 and 25. My question goes to Elisha. What do you do now, Eli? Just an idea. I'm asking an idea.
So is it like you add the 2 and divide by 2 or something?
What? Exactly. We have to go for an average temperature. Because now it's the situation is complicated. The initial temperature mention karaganda beha. Ikkene 25 and 26. What do? You go for an average initial temperature. How do you do that? Like Ellie said, add the 2 and divide it by 2, and then you will get the average initial temperature. And we are going to consider that temperature as the initial temperature of both of them. Simple katawa, right? Niyamai. Hondai. Kanik Elisha ke prashna hanno ne toda වැඩි full active එක ඉන්නවා. Right. Okay. So let's do like this. Okay. Write a point. If both the reactants උපේ වරන්ඩ උපේ උපේ උපේ
Yeah,
කා
sir. Yeah,
මොකද
I'm here.
එලීෂාගේ ඩියුටි මාරු කරගත්තද ඔයා?
So තරහයි.
Right. කවුද තරහ? ඇයි? කවුද එහෙම කිව්වේ? හෙලෝ මොකද්ද උපේ?
I didn't say anything, Shanati told.
Right, okay. Right, okay. Let's try like this. Okay. Right. If both the reactants before the reaction, before the reaction has the same temperature, if both the reactants before the reaction has the same temperature, if both the reactants before the reaction has the same temperature, that can be considered as the initial temperature. Then again 25 that can be simply considered as the initial temperature. Shape ready. Okay. If both the reactants before the reaction has the same initial temperature, that can be considered as the initial temperature. Done. If both the reactants before the reaction has the same initial temperature, that can be considered as the temperature initial of the reactants. Okay, simple. Next point. If the two reactants, if the initial temperature of the two reactants, are different, if the initial temperature of the two reactants are different, an average initial temperature, an average value, sorry, an average temperature, an average temperature, an average temperature, an average temperature can be taken as an average temperature can be taken as an average temperature can be taken as the initial temperature. An average temperature can be taken as the initial temperature, right? Okay, now what do we do? Then method temperatures dekak. Meya T1 කියලා හිතමු. Temperature 1, initial temperature 1. Meya initial temperature 2. How do you do that now? Add them 2 and divide it by 2. Okay, right. So then now we have a problem. We had a problem of finding temperature initial, so we go for an average temperature initial. Average temperature initial. How do you do that? Add the temperature 1 of one reactant, add the temperature 2 of the other reactant, and then divide it by 2, and then you get the average initial temperature of the two reactants, right? Go for it very quickly. Note this down. All right. So now we have sought out finding out the initial temperature. Can then so if you have written it so far, api tama theta heguwe ne ya. Theta hoyanna temperature final වලින් temperature initial අඩු කරන්න ඕනේ. තාම අපි deal කරන්නේ temperature initial එක. Temperature initial හොයනකොට අපිට problems දෙකක් එන්න පුළුවන් possibility එකක් තිබ්බා. මොකද්ද? ඉස්සල්ලාම reactants දෙකේම එකම temperature එක නම් that is considered as temperature initial. Reactants or initial temperatures වෙනස් නම් we are going to consider average temperature initial. How do you do that? Add the two reactants temperature initial temperature and divide it by 2. Okay. ඒක finalize කරගෙන තාම අපි temperature initial කොහොමද හොයාගන්නේ කියලා විතරයි බැලුවේ. Then we have to consider how to find out the temperature final. Then only we have to subtract temperature initial by the final and then find out theta. එතකොට තමයි මේ equation එකේ එක component එකක් අපි හොයලා ඉවර වෙන්නේ. මේ equation එකේ අපේ තිබ්බනේ equation එක. This equation මේ equation එකේ එක component එකක්. theta කියන component එක හොයලා ඉවර වෙන්නේ එතකොට. Right? Okay. Right. I hope you should have written this, right? How to find out the average temperature. Okay. Then we are done finding out temperature initial, and then write a point when finding another point when finding out the temperature final of the reaction. When finding out the temperature final of the reaction, the following assumption has to be made. The following assumption has to be made. Okay, then we are assuming a thing to help us to find out the temperature final of this reaction. Okay, in an assumption 1 කියලා ලියා ගන්න. Assumption 1. Okay. Okay. Then මොකක්ද වෙන්නේ? අපි දන්නවා when the two reactants are reacted. දැන් මෙන්න reaction එක when the two reactants are reacted, react වෙනකොට මේක ඇතුලේ heat එක produce වෙනවා. මේක ඇතුලේ heat එක produce වෙනවා. ඒ heat එක නිසා මෙතන තිබ්බ temperature එක should increase. That's what simply happens, right? අපි මෙතනින් NaOH දැම්මා. Methane HCl දැම්මා. When these two are reacted inside the reaction chamber, මේක ඇතුලේ heat produce වෙනවා. ඒ heat produce වෙන හින්දා මේ chamber එකේ heat එක increase වෙනවා, temperature increase වෙනවා. ඒ heat එකම තමයි එළියට යන්නේ, right? So initially what happens when these reactants are reacting, the temperature inside the reaction chamber increases. එහෙනම් ඒ increase වෙනාම තමයි temperature එක මේක ඇතුලේ වැඩි වෙන්නේ. That value is considered as the temperature final. අපි ඒකනේ consider කරන්නේ. Right. එහෙනම් මම ආයෙ ප්‍රශ්නයක් අහනවා. ඔන්න අහගන්න. දැන් ඔන්න මම ආයෙ පොඩ්ඩක් ඒක simplify කරලා brief කරලා දෙනවා ඔයාලට. What happens We have the reaction chamber. We have the reaction chamber, right? In this reaction chamber, අපි මොකද කරන්නේ? මේ පැත්තෙන් we add sodium hydroxide. මේ පැත්තෙන් we add what? HCl. Okay. මේ දෙන්න react වෙනකොට what will happen inside the reaction chamber? Heat will be generated. Heat will be generated. So during the reaction, when the heat is generated inside the reaction chamber, අර උපේට උදා වගේ මෙන්න මේක ASCII heat එක වැඩි වෙනවා. Right? මෙන්න මේක ASCII heat එක වැඩි වෙනවා. So then the temperature, මේක ඇතුළේ heat එක වැඩි වෙනවා කියන්නේ temperature here what happens? Increases. Temperature increases. මේක ඇතුළේ මේ දෙන්න react වෙනකොට මේක ඇතුළේ heat එක generate වෙන හින්දා temperature here increases. Okay? Right. So then if you put a thermometer here, due to the reaction amount, due to the amount of heat produced here, මේ thermometer එකේ ඒ heat එක sense කරපුවාම අපිට temperature final එක read කරලා දෙනවා. ඕක තේරිච්ච කට්ටිය අත උස්සන්න. මේ දෙන්නව react කරනකොට ඇතුලේ heat එක generate වෙනවා. ඒ heat එක thermometer එක sense කරපුවාම මේක ඇතුලේ වැඩි වෙච්ච temperature එක display කරනවා. එළිය එක තේරුම් නැද්ද? Upe, Eli, didn't you get that? Okay, fine. Then, then question is there, Eli. It was a shadow turning. Eli, listen. Are you there, Eli?
Yes, sir.
Eli, what if the heat generated inside the reaction? What if the heat generated in the reaction, right, was simply lost to the external environment? දැන් මම ඔයාට කිව්වා මේ thermometer එකට මේක ඇතුලේ generate වෙච්ච මේක ඇතුලේ මේ දෙන්න react වෙනකොට heat එක generate වෙනවා. ඒ heat එක thermometer එක sense කරපුවාම තමයි thermometer එකේ මේකේ වැඩි වෙච්ච temperature indicate කරන්නේ කියලා. හැබැයි what I'm asking from you is මෙතන generate වෙන heat එක thermometer එක sense වෙන්න කලින් එළියට ගියොත් මොකද වෙන්නේ? එළියට යනවා. Actually, මේ දෙන්න mix කරපුවාම heat එක generate වෙනවා. Generate වෙන heat එකට ඔක්ගාලා එළියට යනවා. thermometer එකට sense කරන්න හම්බෙන්නේ නැහැ. එතකොට thermometer එක මෙතන increase වෙන temperature එක මට පෙන්නයිද නැද්ද? What do you think? Increase වෙන temperature එක පෙන්නයිද නැද්ද?
Sir, it will increase a little, but
Not exactly, isn't it?
yeah.
එතකොට මට මේකේ මේ reaction එකකින් generate වෙන heat එක නිසා increase වෙන exact temperature එක measure කරගන්න ඕන නම් tell me, should I let this heat to go out or should I make it stay inside the reaction chamber?
You should make it stay inside.
Yeah, when they are mixing together, the heat generated here will result for the final temperature of the reaction. So if the heat was lost to the external environment, thermometer will not sense the amount of heat extra generated inside the reaction chamber. So the thermometer will show a lesser reading, as Eli said. Not the exact generated heat will be marked by a thermometer, right? Because when the heat is lost to the external environment, thermometer can make us increase the high temperature. So then what should I do if I really want to calculate how much of real heat increases here, how much of exact number of exact value of the temperature increases here? If I want to calculate the exact amount of temperature increment here, I should not let a single joule of heat to be lost to the external environment. ඇයි heat එක එළියට ගියාම කොහොමද thermometer එක sense කරන්නේ මේ එළියට ගියපුට heat එක? එතකොට thermometer එක කොහොමද දැනගන්නේ මෙතන මෙච්චර heat එකක් produce වෙනවා. ඒ heat එක නිසා මෙච්චර temperature එකක් final increase වෙනවා. There's no way. එහෙනම් what should I do? Temperature final එක හරියට measure කරගන්න ඕන නම් මට කරන්න වෙන්නේ මේක ඇතුලේ generate වෙන heat එක මේක ඇතුලේම තියාගන්න වෙනවා. එතකොට තමයි මට exactly දැනගන්න පුළුවන් ඉන්නේ කොච්චර amount එකක් heat එක generate වුණාද කියලා temperature එක බලලා. heat එක generate වෙන ගමන් එළියටත් යනවා. ඒතර එලිෂන් කිව්වා වගේ හරියටම එලිෂන් කිව්වේ හරියමක generate වෙන ගමන් එළියටත් යනවා. ඒතර thermometer එක sense කරන්නේ පොඩ්ඩයි. ඇයි ඒ? එළියට ගියානේ ගොඩක් නේ. පොඩ්ඩයි sense කරන්නේ. මේක ඇතුලේ තියෙන එක විතරයි sense කරන්නේ. එතකොට එහෙනම් හරියට මෙතන increase වෙන temperature එක measure කරගන්න හරියට මේක ඇතුලේ produce වෙන heat එක measure කරගන්න what you have to do, you should not let any amount of heat to lose. එහෙනම් ඔයා මේක perform කරන්න ඕන well insulated reaction chamber එකක. ඒ කියන්නේ මේක ඇතුලේ ප්‍රොඩියුස් වෙන හීට් එක මේක ඇතුලේම තියෙන්න ඕන. එතකොට මගේ තර්මෝමීටර් එක සෙන්ස් කරනවා කොච්චර amount එකක් හීට් එක ප්‍රොඩියුස් වුණාද කියලා ඩිග්‍රී සෙල්සියස් වලින්. මේ දෙන්න රියැක්ට් වෙනකොට මේක ඇතුලේ ජෙනරේට් වෙච්ච හීට් එක මේක ඇතුලේම කම්ප්‍රෙස් කරලා තියාගත්තොත්, හිර කරලා තියාගත්තොත් thermometer එකට පුළුවන් මේ total amount of heat generation එක sense කරලා අපිට කියන්න how much of temperature, how much of heat was generated here finally කියලා. Is it clear to you? Shanuk, is it clear? Upe, is it clear?
Yes, sir.
Yes, sir.
Upe, right, okay. Bima, එක clear ද පුතා? Right, hari. එහෙනම් අපි මෙන්න මෙහෙම ලියමු. Assumption. Here the final temperature is resulted. Here the final temperature is resulted. Here the final temperature is resulted. Here the final temperature of the mixture is resulted. Here the final temperature of the mixture is resulted. Here the final temperature of the mixture is resulted. Due to the amount of heat produced by the reaction of HCl and NaOH. Due to the reaction of HCl and NaOH, due to the reaction of HCl and NaOH, inside the reaction chamber, right like that. Due to the reaction of HCl and NaOH inside the reaction chamber. Okay, then right. Therefore, we assume the heat generated. Therefore, we assume the heat generated. The reaction. Therefore, we assume the heat generated during the reaction is not lost to the external environment. Therefore, we assume heat generated during the reaction is not lost to the external environment. Therefore, we assume heat generated during the reaction is not lost to the external environment. Which means this reaction has to be performed. Which means this reaction has to be performed. Which means this reaction has to be performed in a well thermal insulated reaction chamber. In a well thermal insulated reaction chamber, which means this reaction has to be performed in a well thermal insulated reaction chamber. Which means this reaction has to be performed in a well thermal insulated reaction chamber. Okay, now see, this is the assumption 2. This is the assumption 2. Assumption 2 is we assume the heat generated during the reaction is not lost to the external environment. That's what the assumption is. Then එහෙම lost to not. Imagine කරපු අපේ මොකක් හරි mistake එකක් ඉන්න පොඩ්ඩක් heat එක එළියට lost වෙලා. එහෙනම් මෙතන temperature එක එළියට කිව්වා වගේ හරියට final temperature එකක් generate වෙච්ච final temperature හරියට මෙයා read කරලා නැහැ. එහෙනම් අපි we have to be very careful not to let the reaction to lose a single joule of heat, right? එළියට හරියටම කිව්වා මෙතන temperature එක final ඉන්නේ, right? ඉන්නේ අඩු temperature එකක්. එහෙනම් what you have to do, you should be very careful not to let any joule of heat to be lost to the external environment. චුට්ටක් lost වුණත් අපි දෙන final temperature value එක වැරදි. Right? එහෙනම් අපි මොකද කරන්න ඕන මේ reaction chamber එක perform කරන්න ඕන inside a well insulated reaction chamber, making sure not a single drop, not a single joule, not a single tiny amount of heat is lost to the external environment. That's the assumption number 1. දැන් අපි assume කරනවා අපි use කරන well insulated reaction chamber එකෙන් heat එක පොඩ්ඩක්වත් lost වෙන්නේ නැහැ. lost වෙන්නේ නැත්නම් අපි ගත්ත final temperature value එක හරි. කොහෙන් හරි heat එක එළියට lost වෙලා නම් අපිට එන final temperature value එක හරි නැහැ. ඒ කියන්නේ අපේ calculation එකේ error එකක් එනවා final temperature එකේ. right? So එහෙනම් අපි try කරන්න ඕන maximum try කරගන්න ඕනේ to make it to the accurate level by not letting heat be lost to the external environment. එහෙනම් ඔයා මෙතන reaction chamber එකකට ගන්න බෑ metal cup එකක්. අරගෙන කොහොමත් acids දාන්න බෑ metal cups වලට. metal cup එකක් වගේ එකක් කොහොමත් ගන්න බෑ. ඇයි මේ වගේ heat එක එළියට lost වෙනවා. ඇයි metal කියන්නේ thermal conduct එකක්නේ. glass එකක් ගන්නත් බෑ. glass thermal insulators තමයි. අවුලක් නෑ glass එකක් නම් ගන්න පුළුවන්. හැබැයි glass වලට වඩා ටිකක් මොකද glass ඒවත් අල්ලුවම රත් වෙනවානේ. අපි ගන්න ඕන ඇත්තටම සෑහෙන thermal insulating reaction chamber එකක්. අපිට පුළුවන් polyester cup එකක් වගේ ගන්න. අර ඔයගොල්ලෝගේ තියෙන්නේ මේ disposable cups. අන්න ඒ වගේ මේ polyester cup එකක් වගේ තමයි මෙන්න එහෙම ගන්න වෙන්නේ. right? මේ මොකද්ද? polyester cup එක. ඔහොම දාන්න බෑ. polyester cup එක. right? ඊට පස්සේ ඔය polyester cup එක ඔයාට පුළුවන් තවත් polyester cup එකක් අස්සේ කර බස්සන්න. දැන් හිතන්නකො ඕන නම් ඔයාට පුළුවන් මෙන්න මෙතන මෙහෙම මේ cotton wool වගේ දාන්න. right? මෙහෙම cotton wool වගේ දානවා. cotton වගේ දානවා කියලා හිතන්න. දාලා මේක තවත් polyester cup එකක් අස්සට දානවා. දැන් ලොකු එකක් අස්සට. ඕන දැන් හොඳටම thermal insulate කරයි. right? හොඳටම thermal insulate කරා. පස්සේ පුළුවන් මේ උඩට අපි දන්නවනේ අර කෝක් තියෙන්නේ මේ කෝක් ස්ටොපර්ස් තියෙන්නේ අන්න ඒ වලින් මෙන්න මෙහෙම ලිඩ් එකක් හදාගන්න right ලිඩ් එකක් හදාගන්න right ඒතර මම මේකට දාන්නම් මෙතන ඕනනම් දාගන්න cotton කියලා right cotton මේ දෙකම polyester cups polyester cups ඒ කියන්නේ අර්ථ මේ disposable cups ඊට පස්සේ මෙතන චුට්ටි එක හෝල් එකක් තියාගන්නවා අපි තර්මෝමීටර් එක දාගන්න. මොකද අපි ෆයිනල් ටෙම්පරේචර් එක මෙෂර් කරන්න තර්මෝමීටර් එකක් දාගන්න එපා. මේ දෙන්න රියැක්ට් කරද්දීනේ ෆයිනල් ටෙම්පරේචර් එක මෙෂර් කරගන්න. එහෙනම් ඔතනට තර්මෝමීටර් එකක් දාගන්නවා. right? ඔන්න තර්මෝමීටර් එකක් දාගත්තා. ඊට පස්සේ මේ දාපුවා පොඩ්ඩක් මික්ස් කරගන්න ඕනේ වෙනවා. මම කියන්නම් රීසන් එක. මේකට mix them all චුට්ටි හෝල් එකක් තියාගන්නවා. රියැක්ටන්ස් ටික මේකට දාන්නයි. දාලි ඉවරලා ඔය වගේම පොඩි tiny hole එකක් තියාගන්න මෙතනින් glass rod එකක් දාගන්න. මේක මේ seal වෙන්න දාන්න ඕනේ මෙහෙම ලොකු හිල් තියන්න බෑ. මේක glass rod එකක්. glass rod එකක් අපි stir එක විදිහට තමයි ගන්නෙ. stir එක පොඩ්ඩක් mix කරන්න. right? mix කරන්න. අයියෝ උපේ drop වෙලා. right? glass rod එකක් ගන්න stir එක. දැන් එතකොට මේක තමයි අපේ lid එක. right? මේක අර cook වගේ වලින් වගේ හදන්න පුළුවන්. right? මෙන්න මේ තමයි ලිඩ් එක අපේ. ඔය ලිඩ් එක හීල් කරනවා ඒව දාලා තියෙන්නේ. මේක කෝක් ලිඩ් එකක්. හරිනේ? right. ඕක තමයි ඉතින් අපේ රියැක්ෂන් සෙටප් එක. සාමාන්‍ය අපි ඕපන් බීකර් එකක රියැක්ෂන් එක කරන්න බෑ. ඕපන් බීකර් එකක රියැක්ෂන් කරොත් හීට් එක ලොස් වෙනවා. ඒ හින්දා අපි polyester cup එකක් තමයි රියැක්ෂන් එක කරන්නේ. එයා cotton වලින් cover කරලා එයාව තවත් polyester cup එකක් අස්සට දාලා උඩ ලිඩ් එකක් ගහලා කෝක් ලිඩ් එකක් ඒ ලිඩ් එක හීල් කරලා තර්මෝමීටර් එකක් දාලා ඒ ලිඩ් එකම හීල් කරලා glass stir එකක් දාලා තියෙන. ඒකට අපේ රියැක්ෂන් එක වෙන්නේ මෙන්න මෙතන. This is where the reaction happens. right? මෙන්න මෙහෙ තමයි රියැක්ෂන් එක වෙන්නේ. මෙන්න මෙතන තමයි රියැක්ෂන් එක වෙන්නේ. right? මේ තියෙන්නේ මේක අස්සේ තියෙන HCl කොහොම තියෙනවා? HCl sodium hydroxide දෙන්නම තියෙන්නේ උතන තමයි. right? Don't take too much of time. විනාඩියක් දෙන්න පටගල් ස්කෙච් කරගන්න. නැත්තම් ඕක homework එක දුන්නොත් ඔයගොල්ලෝ homework කරන්න O level ඉවර වුණාට පස්සේ. right? ටගල් ස්කෙච් කරගන්න. mixture right tag ගාලා දාගන්න උපේ කොහෙද ගියේ ඔයා I was asking a better setup for this නේ right මේකට වඩා හොඳ setup එකක් නේ ඇහුවේ මම right මේකට වඩා ටිකක් හොඳ setup එකක් කියන්නේ උඹලගේ අම්මලගේ උණු වතුර බෝතලේ මාර් හොඳයි එහෙමයි කියලා දැන් හිතන්නකො උණු වතුර තර්මෝ ෆ්ලාස්ක් කියලා කියන්නේ අපි උණු වතුර බෝතලෙට හුත්ත උණු වතුර එකක් දාලා සතියකින් විතර බිව්වොත් ඒ වගේම රසට තියෙනවද නෑ ඒක ඇල් වතුර වෙලා ගන්න දෙයක් නැති වෙනවා දැන් උණු වතුර බෝතල් වල heat loss එක අඩුයි external environment එකට heat එක දෙනවා අඩුයි උණු වතුර බෝතල්. එයාලා heat preserve කරලා තියා ගන්නවා ඇතුලේ. හැබැයි මේ ඒක මේව නෑ life time නෑ යා. ඒ කියන්නේ පැය 4-5කින් ඒක නිවිලා යනවා. ඒ කියන්නේ heat loss එකක් තියෙනවා හැබැයි මාර minimum. අපි නිකන් කප් එකකට වතුර දාලා තිබ්බම මෙහෙම ගම කරපුවම වතුර නිවෙනවනේ. හැබැයි උණු වතුර බෝතලේ එහෙම ඉක්මනට heat එක එළියට loss වෙන්නේ නෑ. මාර හිමින් යන්නේ ඉඳ පැය 7-8ක් තියාගන්න. right හැබැයි දැන් අපි මේ රියැක්ෂන් එක පැය 7-8ක් කරන්නේ නැහැ නේ පොඩි වෙලාවක ෆයිනල් ටෙම්පරේචර් එක මෙෂර් කරගන්නවානේ උණු වතුර බෝතලයක් අරගෙන උණු වතුර බෝතලේ උඩ තර්මෝෆ්ලාස්ක් එකක් දාන්න ලිඩ් එක හිල් කරලා මෙතන ස්ටර් එකක් දාන්න ලිඩ් එක හිල් කරලා උණු වතුර බෝතලයක රියැක්ෂන් එක පර්ෆෝම් කරොත් පට්ට ඇයි හීට් ලොස් එක මාර අඩුයි කියන්නේ පොඩි ටයිම් එකක් ඇතුලේ මේ උණු වතුර බෝතලේ හීට් එක ලොස් වෙන්නේ නැහැ right කියන්නේ මේකට දැන් ඔයගලන්ට එක්සාම් එකට දෙන්නේ කොහොම තමයි මේ සෙටප් එකට අමතරව ජෙනරලි ගෙදර තියෙන මීටත් වඩා බෙටර් එක්ස්පීරියන්ස් එකක් ගන්න පුළුවන් හීට් ලොස් එක මිනිමම් තියා ගන්න පුළුවන් මොකක් හරි සජෙස්ට් කරන්න තර්මෝෆ්ලාස්ක් එකක් ගන්නවා තර්මෝෆ්ලාස්ක් ගත්තොත් කුටි ගන්නවා ඒක වෙන සීන් එකක් ගෙදරින් හැබැයි ඒ උනට රියැක්ෂන් එක කරන්න හොඳ මේක ඒකේ මාර හීට් ලොස් එක මාර විදිහට මිනිමයිස් කරනවා ඒ කියන්නේ හීට් කන්ඩක්ෂන් එකක් ඇත්තෙම නැහැ නේ කොට තියෙනව නැත්තේ නෑ මාර අඩුයි ඒ කියන්නේ මේකට වඩා සෑහෙන හොඳයි ඒකක් යූස් කරන්න පුළුවන් තර්මෝෆ්ලාස්ක් එකක් යූස් කරන්න heat loss එක ගොඩක් අඩුයි. එතකොට මෙතන ගන්න temperature final value එක මාර accurate. හරිනේ? right. ඒක තේරුණාද කට්ටියට? So then hope you have done with the diagram. Then we are okay finding theta. අපි theta හොයලා ඉවරයි. දැක්කම theta හොයන්න යන වෙලාව ඇයි දැන් මේකේ මේ experiment එකක් carry out කරන්න ගියම මේ experiment එකේ එක cases තියෙනවා right? හරියට theta හොයාගත්තා. right? theta හොයාගද්දි අපිට හිර වෙන්න තැන් ගොඩක් තිබ්බා ටෙම්පරේචර් ඉනිෂියල් හොයද්දී හිර වෙන්න තැන් දෙකක් තිබේ දෙක ගැනම කතා කරා ටෙම්පරේචර් ෆයිනල් ගද්දී හිර වෙන්න තැනක් තියෙනවා හීට් ලොස් වුණොත් අපිට ටයිම් ටෙම්පරේචර් ෆයිනල් එක වෙනස් වෙනවා right so then what did we do we අපි මොකද කරේ මෙතන ෆයිනල් ටෙම්පරේචර් ගන්න හරියට ඇකියුරේට්ලි ගන්න ඕනේ මේ රියැක්ෂන් එක රියැක්ට් වෙනකොට එළියට හීට් එක ලොස් වෙන්න නොදී we kept the heat inside the reaction by using an insulating heat thermal insulating reaction chamber right so එහෙනම් අපේ equation එකේ theta අපි හොයලා ඉවරයි right we are done finding theta hari temperature initial එකත් හොයාගන්න දන්නවා temperature final එකත් හොයාගන්න දන්නවා next one is C specific heat capacity okay specific heat capacity okay right like this point when finding out the specific heat capacity of the reactant of the mixture when finding out the specific heat capacity of the mixture when finding out the specific heat capacity of the mixture, following assumption has to be made. When finding out the specific heat capacity of the mixture, following assumption has to be made. When finding out the specific heat capacity of the mixture, following assumption has to be made. Okay. බලමු මොකද කරන්න කියලා. Then I'll tell you what specific heat capacity is. First of all, දෙක එක දන්නේ නැතුව ඇතිනේ, right? මම ඒක කියලා දෙන්න. අහගන්න. If you have 1 kilo of water, if you have 1 kilo of water, okay? So just imagine and take the point what I say exactly into your mind very correctly. What I'm telling you, you have water and how much of liquid water? 1 kilo. And I'm telling you, you have the temperature of water is 20 degrees Celsius. Temperature of water is 20 degrees Celsius. Okay, water temperature 20, and I want you to increase it up to 21 degrees Celsius. Okay, water kilo එකක් තියෙනවා, the temperature of water is 20. I want to increase it up to 21 degrees Celsius. Shanuki, tell me what should I do now? I have water, 1 kilo of water. The temperature of water is 20 degrees Celsius, and I want it to be increased up to 21 degrees Celsius. That means I'm increasing the temperature of water by 1 degree Celsius. What should I do now? Shanuki, what should I do to increase the temperature of 1 kilo of water by 1 degree? It's a simple question. Huh? Don't think too hard. Just a simple question. It's not related to science and general knowledge. Don't think. Don't think like that, then you go wrong. Huh? So I'm simply asking, Shanuki, can you hear me? Hello, Shanuki, can you hear me?
Sorry,
Upe, can
sir,
you?
I got lost.
Right. Okay. So, Shanuki, now you have what I'm telling here is I have 1 kilogram of water. Okay. How much of water I have? 1 kilogram.
1 kilogram.
Okay. So then the temperature of water is 20 degrees Celsius. Okay. Temperature of 1 kilogram of water is 20 degrees Celsius. I want to increase the temperature of this 1 kilo of water up to 21 degrees Celsius. That means I'm increasing the temperature of water by 1 degree Celsius. Can you see that?
Yes, sir.
So I'm asking, what should I do?
You should.
Simply answer. Simply answer. Don't think too hard. Hey, what should I do to increase the temperature of 1 kilo
Yeah,
of
you
water?
should heat it.
Heat it. Heat it. Okay. So heat it. Simply heat it. So
So
then
you need exactly 25 Celsius.
I'm increasing it up to 21 from 20 degrees Celsius to 21
Yeah.
degrees Celsius. So
Uh-huh.
I'm increasing the heat by 1 degree Celsius.
Yeah.
Okay. So for that I need to heat it. Okay. So the amount of heat කරනවා කියන්නේ මේ ගිනි කූරක් නිකන් ගහගෙන හිටියම මේක 21 වලට increase වෙන්නේ නැහැ නේ right දැන් මගේ body එකේ heat එක තියෙනවා 36 degree celsius වගේ මම මෙයාව අල්ලන් හිටිය කියලා වතුර කිලෝ එක 21 degree celsius වලට increase වෙනවද එහෙම වෙන්නේ නැහැ නේ ගිනි කූරක් ගහන් හිටිය කියලා මෙයා 21 වලට increase වෙන්නේ නැහැ you have to supply some amount of heat නේ ඒක you can understand පොඩි heat එකක් දුන්නා කියලා මෙයා මේ වතුර කිලෝ එක 21 degree celsius වලට heat වෙන්නේ නැහැ නේ we have to supply some amount of heat. So the amount of heat you need to supply is 4,200 joules. Okay, keep it in mind. If you have water, 1 kilo of water, 1 kilo of water, to increase the temperature by 1 unit, if you want to increase the temperature of water by 1 unit, you need to supply 4,200 joules of heat. If you want to increase one temperature of 1 kilo of water by 1 degree Celsius. Take it again to your mind. If you want to increase the temperature of 1 kilo of water by 1 degree Celsius, you need to supply 4,200 joules of heat. That's what the specific heat capacity. The amount of heat should be supplied to increase the temperature of a substance by 1 unit. Sorry, increase the temperature of 1 kilo of a substance by 1 unit. The amount of heat you need to supply to a substance is 1 kilo to a substance of 1 kilo to increase the temperature of it by 1 degree Celsius. It's called specific heat capacity. So do you think the specific heat capacity of all substances would be same or different? What's your idea, Ellie? Specific heat capacity of water, that means water wala kilo ekaka temperature එක unit increase කරන්න you need 4,200 joules. Do you think other chemicals also would have the same exact specific heat capacity? I'm asking like හිතන්නකෝ you have imagine you have how do you say? Imagine you have okay nitrogen. Okay, nitrogen gas. Again, kilo එකක් තියෙනවා. 1 kilo of nitrogen. You need to increase the temperature of nitrogen gas 20 ඉඳලා 21 වලට again 1 unit. The amount of heat you need to supply is මේ ගානම වෙයිද? Would it be a different value? What do you say, Ellie? Is it going to be a same value or different value?
A different value.
Different නේ. ඒකනේ හැම එකම different. ඒ කියන්නේ sub chemicals ගොඩක් තියෙනවානේ we have different chemicals and ඒගොල්ලන්ට එක එක specific heat capacities තියෙන. ඒ කියන්නේ ඒ ඕනම substance එකකින් කිලෝ එකක් ගත්තාම එයාගේ temperature එක to increase by 1 degree Celsius the amount of unit supply is different. So specific heat capacity, what is this? If you have 1 kilogram of water to increase the temperature by 1 kilo of water by 1 degree Celsius, you need to supply 4,200. That is specific heat capacity of water. So specific heat capacity of HCl would be a different value. HCl kilo එකක් තියෙනවා නම් HCl kilo එකක් තියෙනවා නම් මෙයාගේ temperature එක unit එකකින් increase කරන්න දෙන්න ඕන heat එක is a different value. එතකොට NaOH තියෙනවා නම් NaOH kilo එකක් තියෙනවා නම් මෙයාගේ temperature එක 1 degree Celsius එකකින් වැඩි කරන්න දෙන්න ඕන amount of heat එක is different. So specific heat capacity of each element, each compound is different, not same. Okay. However, we have a problem උපේක ශනුකි බිම්සෙන් දැක්කද අපේ equation එකේ දැන් අපි ගාව අපේ reaction chamber එකේ components කීයක් තියෙනවද මේ බලන්න අපේ reaction chamber එකේ final mixture එකේ HCl තියෙනවා NaOH තියෙනවා. ඒතර components කීයක් තියෙනවද compounds දෙකක් තියෙනවා. හැබැයි අපේ equation එකේ specific heat capacity දාන්න specific heat capacity values දෙකක් දාන්න පුළුවන්ද නැත්නම් දාන්න තියෙන එකයිද? Can you see what I'm telling? The අපේ final mixture එකේ we had HCl, we had NaOH. ඒතර ඒ දෙන්නගේ specific heat capacity values equal වෙන්නේ නැහැ different. හැබැයි අපේ equation එකේ තියෙන්නේ 100 අකුරයි එක specific heat capacity එකයි දාන්න තියෙන specific heat capacity දෙකක් දාන්න බෑ. Did you see that? ළමයි can you see what I'm telling you? ළමයි උඹලට මං කියන්නේ කනවද?
Yeah, sir.
ළමයි උපේ are you there? Bimsen are you there?
Yes, sir.
Hey, come on, just talk will you? Bimsen මම ඇහෙනවද?
Oh.
Right. අර දැක්කනේ අර ඉංග්ලන්ඩ් වල ඉන්න ළමයාට සිග්නල් තියෙනවා උපේක ඔයාට අඩා. Right, උපේ talk to me උපේ. Are you there?
Yes, sir.
Okay, do you understand that we have two compounds in the final mixture? හැබැයි ඒ දෙන්නගේ specific heat capacity වෙනස්, but still we have one C. එක specific heat capacity එකයි දාන්න පුළුවන්. තේරෙනවද?
Yes, sir.
Okay, so do we have a problem now? Do we have a problem? Elisha, do we have a problem? ප්‍රශ්නයක් තියෙනව නේද? Because our equation එකේ says about one specific heat capacity, but the practical reaction contains two final compounds, isn't it? In the mixture. Mixture එකේ final compounds දෙකක් තියෙනවා. Can you see that? Elisha, is it a problem now? Problem එකක් නේද?
Yes, sir.
හැබැයි එලි දැන් ඔයාගේ solution එක වැඩ කරන්නේ අර අපි ඉස්සලා final temperature එක හැදුවා වගේ කරන්න බෑ මෙතන. Right? Specific heat capacity average එකක් ගන්න බෑ. Right? එලි මට කියන්න මේ did we write anything after the diagram after this diagram did we write anything?
Yes, sir. About specific heat capacity, 1 point.
What did we write?
When finding the specific heat capacity of the mixture, the following assumption has to be made.
Okay, after that you can write assumption 2. This is the second assumption that we make during the reaction. Okay, assumption 2. Amma adupe enna kammeli kame inniya. Enna upeka මොකද නින්දක් දාලාද ක්ලාස් එකට හැරුණේ?
නෑ.
එහෙනම් මොකද්ද සීන් එක? සයිඩ් එකේ මූවි එකක් බලන ගමන්ද ක්ලාස් එකේ ඉන්නේ?
නෑ.
Okay, right. Okay, assumption 2. Right. දැන් මේක assumption එක. දැන් අපිට මොකද්ද තියෙන case එක? final mixture එකේ මොකද්ද case එක? reactants දෙකක් තියෙනවා. sodium hydroxide and NaOH. කියන්නේ ඒ දෙන chemical compounds දෙකක්. ඒ දෙන්නගේ මේ specific heat capacity දෙක ඇත්තටම දෙකක්. හැබැයි අපේ equation එකේ specific heat capacity substitute කරන්න තියෙන එක value එකයි. එක value එකයි දාන්න පුළුවන් මේ. එක value එකයි දාන්න පුළුවන්. reactants දෙකක් තිබ්බ කියලා දෙකක් දාන්න බෑ. එක value එකයි දාන්න පුළුවන්. හරිද? right. මෙන්න මෙහෙම දැන් අපි මෙන්න මෙහෙම solution එකකට එනවා. ඔකේ solution එකත් පට්ට interesting ඈ. මම දැන් අහන්නම් මේ මම දන්නවා බිම්මා touch එකේ ඉන්නේ කියලා. එහෙනම් මම මේ වැඩිපුර කෙල්ලන්ගේ ප්‍රශ්න අහන්නේ ඒකයි යා. right. නැත්නම් අපේ කෙල්ලෝ දන්නේ නැද්ද? නින්දවත් ගියොත් හදිස්සි කම්මැලි කම යද ඉන්නේ. right. හරි. ඔන්න දැන් එලිගෙන් එහුවා ආයි උපේකගෙන් යා. උපේකා මෙන්න මෙහෙම සීන් එකක් ගන්නවා. right. උපේකා මට ආන්සර් කරන්න. right. උපේකා I have a glass of water. okay. I have what?
Glass of water.
Water. Okay. So then into this glass of water මම මේකට දානවා salt. හරිද? හිතන්නකො දානවා 30 grams of salt. Okay, 30 grams of salt. What do you finally call it?
Salt solution.
Very good. Very good. Salt solution. Okay. And then you drink a drop of it. Do you feel the salt taste?
Yeah.
Okay. So you have what? Okay, I'll just mention the amount of water also I took. Like 100 ml of water I took, and then I dissolved 30 grams of salt, and then you finally called it as an salt solution, and then you could even feel the taste. Okay. Then you pay. Okay. I take this 30 grams of salt. Okay. I go to your Bear Lake. Okay. You have a lake in Colombo or a tank. You have different other tanks also in Colombo. You have tanks in Parliament, like freshwater bodies. But still, let's go to Bear Lake. Joseph border Bimala school border right? So then Bimala roving club right? Okay. So then Colombo rowing club එකේ සෙට් එක වහිනකොට ඔයාලා බලන් ඉන්නව නේද?
සවාල් කප්පේ
ඒකනේ මං කියන්නේ. Right? අරද you have the Bear Lake. Right? And then උපේකගේ 30 grams of salt මං දානවා මේකට. උපේකගේ 30 grams of salt දානවා මේකට Bear Lake මේක. Right? ඒ Bear Lake ඊන විදිය මං දන්නේ නැහැ. Bear Lake. Whatever. Bear Lake. What do you technically call now the water in Bear Lake, Upeka?
So with the salt or without the salt?
Hey, you have added the 30 grams of salt. I know it's hard, but tell me. What do you
So
call?
Bear Lake, salt water.
No, okay, whatever. It's salt water, eh? Salt water. Salt water. Hey, what if you can't ever do that, right? But just imagine if the Bear Lake was very pure. If you drink a little bit of water, do you feel the saltiness? Technically, we can call it salt water because fresh water mixed with salt. Okay, salt water. Technically, the term is right. But can you feel the salty taste, Upeka?
A little.
Upeka, are you
Can.
serious? Bear Lake is a huge amount of water with 30 grams salt. You can make it salty in taste. Upeka, have you seen Bear Lake? It's very large. If for 100 ml of water, your 30 grams is considerable. Yeah, you can call it salt solution. Plus, you can feel the salty taste. But to Bear Lake, salt water, technically we can call it. Theoretically, salt plus water, salt water. Salt plus Bear Lake water, Bear Lake salt water. Okay. But if you test a drop of salt, a drop of water, can you feel the salty taste? Come on. Make a dada lokui. But still, just imagine it's a large reservoir of fresh water. Okay, it's a large reservoir of fresh water, right? And then you add 30 grams of salt into that, and you technically call it salt water because fresh water has the salt water. But if you taste it, can you feel the salty taste? No. No, right? Because it's a huge amount of water with huge amount of water against 30 grams of salt. You can't taste it, but theoretically salt water is. Shanuki, did you get that, Nangi? Right?
Yes,
because theoretically salt plus water, but when you taste it from Bear Lake, you can't feel the taste because right, we are 30 grams, a huge amount of water. Right? 100 ml of water, 30 grams, you can feel it. Okay, so we assume our reaction is all the same. That means අපි assume කරනවා මේ බිමා මේකේ තියෙන්නේ right මේකේ තියෙන්නේ ගොඩක් වතුර Okay, here we assume majority amount initial reactant එකේ මෙයාගේ majority තියෙන්නේ වතුර. හරි බීරල් එකේ scene එක වගේ. ගොඩක් තියෙන්නේ වතුර චූට්ටම චුට්ටයි sodium hydroxide. Theoretically කවුද මේ? Sodium hydroxide solution. හැබැයි ගොඩක් තියෙන්නේ බීරල් එකේ වගේ මොනවද? majority මොනවද? වතුර. චූට්ටම චුට්ටක් මොනවද? sodium hydroxide. Theoretically sodium hydroxide solution එක තමයි. මෙයත් එහෙමයි. ගොඩාක් තියෙන්නේ water. You have a very little amount of HCl. Theoretically කවුද මෙයා? HCl aqueous solution. හැබැයි to be real මෙතන තියෙන්නේ very tiny amount of HCl, majority තියෙන වතුර. Now එතකොට බැලුවහම මේ දෙන්නමනේ final mixture එකට දාන්නේ. Final mixture එකේ majority තියෙන්නේ වතුර. චුට්ටිම චුට්ටි amount එකක් NaOH තියෙනවා, චුට්ටිම චුට්ටි amount එකක් HCl. දැන් මට තියෙන්නේ මෙන්න මෙහෙමයි. කොහොමද ඉස්සෙල්ලා මම පොඩ්ඩක් ඒක verify කරගෙන කොහොමද අපි HCl solution එක හදන්නේ? Right? HCl solution එක හදන්නේ කොහොමද? Right? කොහොමද HCl හදන්නේ? HCl කියන acid එක ගන්නවා. අරගෙන එයාව mix කරනවා water වලට. Then only you can form HCl aqueous. පුතේ ඇත්තටම HCl කියන්නේ vape එකක්. 100% HCl vape එකක්. එයා acidic නෑ. When you mix it with water only, it becomes HCl aqueous and then it is acidic. Then it is acidic. දැන් එතකොට මෙතන මොකක්ද අරන් දෙන්නේ? HCl අරන් දෙන්නේ චුට්ටයි. Very tiny. Water you have taken a lot. Technically it's HCl acidic. But have a majority you contain water here. Did you understand it? Guys, did you understand it? The other thing is also the same. Other thing also the same. Other thing also the same. Right? It's also the same. Right? NaOH. NaOH කියන්නේ pellets ඉන්නේ. solid එකක් ඒක නම් එන්නේ. ගන්නවා water ගොඩක්. අරගෙන dissolve කරලා හදනවා NaOH aqueous. Okay? So මෙයාගේ චුට්ටයි ඉන්නේ. මෙයාගේ ගොඩක් තියෙනවා. Technically you can call it NaOH aqueous, but ලොකු water amount එකකට පොඩි NaOH ටිකක් තමයි දාන්නේ. ඒතකොට finally මෙයාගේ බලුවා මෙයාගේ water ගොඩයි HCl පොඩ්ඩයි. මෙයාගේ water ගොඩයි NaOH පොඩ්ඩයි. ඒතකොට finally මේ mixtures දෙක mix කරපුවාම finally මොනවද තියෙන්නේ වැඩිපුර? majority තියෙනවා වතුර. Tiny amount එකක් HCl and tiny amount එකක් NaOH තියෙනවා. Put up your hand those who got it. Okay. ඒ කියන්නේ මේ අපේ final mixture එකේ ඒ කියන්නේ මේ අපේ final mixture එකේ අපේ final mixture එකේ මේ final mixture එකේ majority තියෙන්නේ water. Very minimum amount වලින් තියෙනවා NaOH and HCl. ඇයි අපි මෙතනට use කරේ මෙතන concentration එක මෙහෙම තිබ්බට අපි finally මෙතනින් ඇත්තටම කොච්චර number of moles mix වුණාද කියලා බලනවා. ඔයාලා බලන්න 0.1 moles add වෙන්නේ. ඒ කියන්නේ බාර පොඩි amount එකක් HCl NaOH add වෙන්නේ. වැඩිපුර මෙතෙන්ට add වෙන්නේ water. Okay? So write like this. Assumption 2. Since we have used very diluted HCl aqueous, since we have used very diluted HCl aqueous, in the sense it's like this, HCl aqueous and NaOH aqueous since we have used very diluted HCl aqueous and NaOH aqueous, we assume the specific heat capacity of the final mixture. We assume the specific heat capacity of the final mixture. Is nearly equal to the specific heat capacity of water. Not exactly equal. කොහොමත් මෙතන final mixture එකේ. So if you consider this final mixture, ඇත්තටම components තුනක් විතර තියෙනවනේ නේ. Final mixture එකේ 100 centimeter cubes තිබ්බනේ අපි දැම්මහම ඕකේ water තියෙනවා, right? HCl තියෙනවා, NaOH තියෙනවා. එතකොට specific heat capacity exactly water specific heat capacity sharp equal වෙන්න බෑ. ඇයි මෙතන specific heat capacity water විතරක් නෙමෙයි එකම compound එක. You have HCl and NaOH as well. So because of that, the specific heat capacity of this final mixture is not the exact value which is equal to the specific heat capacity of water. හැබැයි මෙතන majority මොනවද? මේවා හින minute amounts වලින් තියෙන්නේ. What is majority here water? So we assume the final mixture would have a specific heat capacity that is very much similar to the specific heat capacity of water. It's not true at all. It's not exactly true. The specific heat capacity of the final mixture has to be a different value than the specific heat capacity of water. Because it has water, HCl and NaOH, even though it is in small amounts, HCl and sodium hydroxide are present here. So the specific heat capacity of the final mixture is not exactly 4,200 joules per kilogram per degree Celsius, which is the specific heat capacity of water. But still, we have to assume a majority of the components in the final mixture is water. We assume our specific heat capacity of this final mixture is much likely to be similar to the specific heat capacity of water. Okay, right? So specific heat capacity of the final mixture is nearly equal to the specific heat capacity of the water. Specific heat capacity of water. Okay, that problem all sorted. So what is the way how we sorted it is like this. So what do we take as a C? We take C of water. We take C of water, specific heat capacity of water. This has to be a simple C of water, which is 4,200 joules per kilogram per degree Celsius. A final mixture assumed to have majority of water molecules. So we assume the final mixture specific heat capacity is much nearer to the specific heat capacity of water. So because of that, what do we substitute here? The specific heat capacity value of water. That's what we do here, right? So then we have sorted out theta, and we have sorted out C, and then we have the problem with mass. Okay, right? Quickly go to the third one. The final thing, right, like this. When calculating the mass of the final mixture, next point. When calculating the mass of the final mixture, when calculating the mass of the final mixture, following assumption is made. Then again, I have problem එකක් තියෙනවානේ. Final mixture එකේ මොනවද තියෙන්නේ? We have water. Majority is water. We have HCl. We have NaOH. දැන් මේ හැම molecule එකකම බර එක වගේ නෙමෙයි. Okay? එක එක ඒවා තුන් જાතියක් තියෙනවා. හැබැයි we have in the equation අපිට mass එක substitute කරන්න කීයක් තියෙනවද? We have only one component to substitute mass. If you could see it very carefully. Okay? See here අපිට mass එක substitute කරන්න තියෙන එක component එකයි මේ. Mass of the final mixture. So when you have three components, like three particles in the final mixture, you would find it difficult to find out what is the mass here. We have already made an assumption, make a majority in water. Okay, we have made an assumption when we are calculating the specific heat capacity of the final mixture. We assume that the majority of the components here are water molecules. So the specific heat capacity of the mixture is water, is nearly equal to water. So then we assume කරනවා. දැන් බර බලන්න කියලා කිව්වම මේක මෙෂර් කරන්න බෑ. මේක බර ස්කේල් කරන්න බෑ. මේ වැලි මේකක තියලා. මොකද මේ weight එක මයින් එකක තියලා බර බලන්න බෑ එහෙම. Right? Because ඒක අපි ගන්නනේ මෙහෙම. අපිට assume කරන්න වෙනවා මෙයාගේ density එක. Right? මේ mixture එකේ density අපි දන්නවනේ density කියන්නේ rho equals m over v. Rho equals m over v. එතකොට density into volume එක ගත්තාම mass එක හොයාගන්න පුළුවන්. This is how we find out. එතකොට මේකේ mass එක හොයන්න නම් first thing what we have to know is the density. Okay? So if you knew the density, you know the volume. Volume here is 100 centimeter cubes. මෙයාගේ volume එක 100 centimeter cubes. If you knew the volume, you can multiply it by volume and then you can get the mass of this mixture, right? So what do we have to do? Find out density. So then we are making an assumption again. අපි assume කරනවා මේ mixture එකේ majority is water නිසා the density of this mixture is also similar to the density of water. Okay, and මේ mixture එකේ තියෙන components වල density එක equals to the density of water. So ඒක දන්නවා නම් අපිට මෙතන මේ rho equals MOV work out කරලා mass of the mixture හොයාගන්න පුළුවන්. පොඩි complicated calculation එකක් මම ඒක වට විතර කරලා දෙන්න simplify කරලා ගන්නවා මම value එක. එහෙනම් ලියා ගන්න ඕනේ මෙහෙම. Assumption 3, when calculating the mass of the mixture, following assumption has to be made. So then after write assumption 3, write like this. Since majority of the mixture contains water, density of the mixture is assumed to be nearly equal to the density of water. Density of the mixture is assumed to be nearly equal to the density of water. Okay, density of the mixture is assumed nearly assumed to be nearly equal to the density of water. Okay, and then you can write this equation. This is how we find out the value. Density equals mass over volume, so subject mass, then you can find out the mass. So what do we consider here? Density of water. The density of water, you have to know it, that is 1000 kilograms per cubic meter. Okay, so then 1 centimeter cube of water, right? 1 centimeter cube of water, it's 1 centimeter cube of water. 1 centimeter cube of water, H2O, would have a mass of 1 gram. Okay, so 1 centimeter cube of water would have a mass of 1 gram. So අපේ mixture එකේ 100 centimeters තිබ්බා. එහෙනම් 100 grams තමයි final mixture එකේ mass again, right? So then density of, write this one, density of water is 1000 kilograms per cubic centimeters, so cubic meters. So then simplify it, then 1 centimeter cube of water will be equal to 1 gram. Okay, done. So then we have found out all the components, and then you can calculate it, no? Right? So mixture had 100 centimeter cubes, right? Because 50-50 sodium hydroxide, 50 HCl 50, then I'm going to come 100 final mixture again, 100 grams of final mixture again. Okay, 100 grams, right? Okay, all right. Okay, so then you have found out every component in the equation. You have found out theta, and then you have found out specific heat capacity of the final mixture, and then the mass of the final mixture. Simple final thing. You need to do the calculation. I'll give you the details and then do the calculation. So write like this. So specific heat capacity of water, I think I didn't give, no? I think I didn't ask you to write it. So under assumption 2, I think under assumption 2, specific heat capacity of the mixture is assumed to be nearly equal to the specific heat capacity of water. Specific, sorry, simple C, yeah. Under assumption 2, specific heat capacity of the final mixture is assumed to be nearly equal to specific heat capacity of water. That's what you have written. So under that, write simple C H2O, which is specific heat capacity of water. That is 4200 joules per kilogram per degree Celsius. This is per kilogram per degree Celsius. That is the value. Okay. Okay. Right. Okay. So then, write a question. Write a question. If the details relevant to the above reaction question, if the details relevant to the above question are below, are like below. If the details relevant to the above reaction are like below, find out the heat exchange. If the details relevant to the above reaction is that above reaction are like before, find out the heat exchange. So then I'm giving you theta, temperature change in the above reaction. I'm giving you the temperature change. I'm not letting you to calculate it all. I'm giving you the theta. Theta is temperature difference. That means temperature final minus temperature initial. Where value I'm giving you as 10 degrees Celsius. I'm giving you theta. Okay, temperature final minus temperature initial 10 degrees Celsius. Okay, theta value එක කෙලින්ම දුන්නා මම. ඒ කියන්නේ මේක work out කරපුවාම එන්නේ 10 degrees Celsius. Okay, specific heat capacity of water is 4200 joules per kilogram per degree Celsius. Okay, okay. And mass of the final mixture, it's mentioned 100 grams. Okay, and then do the calculation and find out how much of heat is lost to the external environment. Nikama Q equals MC theta දාන්න components එක දීලා තියෙන්නේ. So then do the math. බීමා මොනවා හරි අහන්න ගියාද ඔයා?
Assumption 3 එකෙන් පස්සේ අපෝ
assumption 3 එකෙන් පස්සේනේ. If the details 3 එකෙන් පස්සේ කියන්නේ 3 එක ලිව්වේ නැද්ද ඔයා?
3 එක ලිව්වා ඊට පස්සේ.
හරි right. එහෙනම් ලියන්න if the details relevant to the above reaction is as below. If the details relevant to the above equation as below, find out the heat exchange. If the details relevant to the above reaction as below, find out the heat exchange. Okay, do it. Upe, you need to tell me the answer. Shanuki Karanda, Ili, I'm going to ask the answer from you also. Right. මෙතන බිංදුව දෙකට මෙතන බිංදුව දෙක කපන්න මේ බිංදුවට මේ බිංදුව කපන්න ඉතුරු වෙන්නේ කීයද 4200 joules විතරයි ඉතුරු වෙන්නේ උපේ ඔයාට ඔක ආවද
Yes, sir.
බොරු කියන්න එපා උපේ grams kilograms convert කරේ නෑ නේද
කරා.
හොඳයි එළිය ආවද ඔය උත්තරේ
Sir, grams, kilograms convert
කරේ නෑ right okay hari Shanuki, what about you? Did you get the answer?
Yes, sir.
Okay, right. Bima, what about you? Bima, මොකද කරගත්තේ?
හරි
මේක ආවද?
ඔව්
Okay. ඒ කියන්නේ during this reaction joules 4200ක් මොනවා වෙලාද? heat එක එළියට ගිහිල්ලා. joules 4200ක් heat එක එළියට ගිහිල්ලා. Okay. Right. මට බිමා පොඩ්ඩක් හිතලා කියන්න එහෙනම් මේ ටෙම්පරේචර් එකේ මේ රියැක්ෂන් එක වෙනකොට හොඳට මතක පොඩ්ඩක් හිතලා කියන්න. ඔයාලට කියන්න පුළුවන් වෙයි කියලා හිතනවා. දැන් ඉනිෂියල් ටෙම්පරේචර් එක අපි ගත්තේ 25 degree celsius කියලානේ. රියැක්ෂන් එක වෙනකොට රියැක්ෂන් චේම්බර් එකේ ටෙම්පරේචර් එක කොච්චරක් උඩ ගිහිල්ලාද? එන්වයරන්මන්ට් එකත් 25 කියලා හිතන්න. රියැක්ටන්ස් වල ඉනිෂියල් ටෙම්පරේචර් එකක් තිබ්බේ 25 කියලා හිතන්න.
question එක
හරි මං අහන්නේ